Okay, so last video, real quick. Again, just this right here is a reminder about independent events because you have a question on your homework. Um, Let me just help you out here, give you a little hint. So remember that independent means that the two events, they don't depend on each other, right? For example, you got a bag of marbles, you take one marble out, and it's green, and that's great, but you put it back and then you grab another marble. Those are independent, right? The probability that you getting a certain color on the first try is going to be the same on the second try if you replace it. So I'm just going to write here, remember that's with replacement is independent events. Now, if you do not replace, so without replacement, you take the marble out and you don't put it back in, well, then the next time you do something, isn't that going to depend on the outcome of the first event? Yes, it is. So when we're talking about dependent events, remember that that is going to be, sorry, you know how I like my colors. That is going to be without replacement. Okay? Sorry. Okay. So just keep that in mind as we do this last example. So this is a new formula here. The probability of A and B is equal to the probability of A times the probability of B given A only if the events are dependent. Okay, so you have to think about whether or not they're dependent. If they are, you can apply this formula. Oh no. Okay, we're almost done. You know I like to live on the edge, right? Okay, so probability of A then B. That's another. Oh, this is another way of thinking about it. So these are the same formulas, but you're going to see, especially if you look at the question help, they like to use this instead. Probability of A then B is equal to the probability of A times the probability of B after A. So that's the same thing as the formula above, maybe a little easier to think about, okay? Or if you don't like that, you can just know the one above. All right, here's how we apply that though. So example 4, it says in a bag of 3 orange marbles, 2 purple marbles, and 3 green marbles, you pick a marble and then pick another without replacing the first. Okay, so first key there, without replacement, guys, that means it's going to be dependent. So make sure that you're kind of checking and asking yourself, okay, is this an independent or a dependent one? Okay, since it's dependent, then I can use the formula above. And it's asking what's the probability that I get a green marble first and then a orange marble second, right? So that's the same thing as the probability of green then orange would be the same as the probability of green and orange, which is probability of A times probability of B given A. Okay, but I'm going to use this one here. This, can you see this? This one here, because I just like it better. It makes more sense. So the probability of green then orange is going to be, based on the formula, the probability of the first one, so green, multiplied by the probability of getting orange after green. Right? Because that makes sense. You're taking a green marble out, you're not replacing it. Then you have to figure out, well, now what's the probability of getting an orange now that the green has been taken out? Okay? I feel like we've done problems like this. All right, so let's do that. So the probability, for this first part, the probability of green, before we do anything, is just going to be the number of green, 3, out of the total number of marbles. So that's 3 plus 3 plus 2, that's 8. Okay, and then we do, let's do green. Okay, probability of O after G, so orange after you take one green out. So I subtract one green away, so now it's only two greens. But there's still three oranges. The only thing that's changed now is the total number. So now it's one less than 8. And then multiply. Ta-da! So on the top, 3 times 3 is 9. And 8 times 7 is 56. And I cannot simplify that, so that is my answer. Okay? Okay. So, yeah, that's it for probability. I hope you enjoyed it, even though it's not really related to geometry. Geometry's better, just saying. But probability is important, guys, and it will be on the SAT. So don't worry, all you sophomores. Next year, as juniors, you will definitely be reviewing this in your math classes, as well as other, SAT prep things. And I know we didn't really get to do a lot of SAT prep, but that's okay. You can do it next year. There's always Khan Academy. Okay, we have that set up now, so that's good. Yeah, okay. Did I mention that you guys are wonderful and perfect and beautiful in every way? It's because you are. Okay. Hope you're doing well, staying safe, not going too stir crazy, and I miss your faces. That is all. Oh, you know what we didn't do at the beginning? So now we have to do at the end. Oh, this coffee. How could I forget the last probability lesson? No. Okay, ready? Nice and loud for your whole household to hear. You know what I'm about to ask. You know the answer. Ready? Okay. Yay, math! Yay, math! Good job. Okay, so proud of you. You're wonderful. Have a wonderful week, guys. Bye.